how to determine the electric field due to a uniformly charged ring. And with the help of this result, I will discuss with you how to obtain electric field due to a uniformly charged disk. Hello students, I am Sumit, a faculty at Toppers Academy, and in this video I am going to discuss with you how to determine the electric field due to a uniformly charged ring. And with the help of this result, I will discuss with you how to obtain electric field due to a uniformly charged disk. So what I am going to do here, let's suppose there is a ring. There is a thin ring which is uniformly charged, right? That is charge is continuously distributed at the circumference of this ring. And let me consider that linear charge density is lambda. That linear charge density is lambda. Suppose there is a charge which is uniformly distributed over it, okay, and we are considering that linear charge density in this case is lambda. So what units this lambda has? It is Coulomb per meter, right? Coulomb per meter. Now we want to obtain electric field at its axis. At a point, let me take that point as P. So I want to calculate electric field at this point P, which is at a distance x from the center of this ring. And let me take this center is O. Okay, one more thing that I have to consider here, that ring is having a radius r. Okay, so this is our system. Here on this ring, a charge is uniformly distributed with linear charge density lambda, Coulomb per meter, and our task is to determine electric field at a point P which is lying on its axis. That is a line which is perpendicular to its plane and passing through the center of it. Okay, so let me consider a small charge element, an infinitesimal charge element at the circumference of this ring, and let it be that this is our infinitesimal charge element at the circumference of this ring. Okay, now let me take that this element, it is having a length, and that length is dl. Okay, length, so let me write here that infinitesimal charge element of length dl. Okay, if this much is the length of this element, then what will be the charge? Okay, that charge, that infinitesimal charge on it, that will be equal to lambda dl. That will be equal to lambda dl, right? Now what will be the electric field due to this charge element at this point? Okay, so that electric field, that will be in this direction, right? That will be in this direction. Suppose this is making an angle theta with the horizontal axis. Okay, theta with the horizontal, and I am taking it to be as a x-axis, right? That this axis of ring, that is along the x-axis. Okay, so now if I want to write electric field due to this charge element, that electric field This is what? This is charge at the element, okay? And what will be the electric field? Electric field due to charge element, okay? Due to charge element of length dl. As this charge element is having this much charge, so I can write that electric field due to this charge element, that will be equal to k dq divided by r square. Now what is r here? That r is the direct distance of this point from this charge element. So this is your r. Okay, now what this r is, I can see from this right angled triangle. Here this angle is right angle one. So I can write from here that this small r is actually the square root of x square plus r square. So I can write that this r, this is small r, that will be equal to square root of x square plus r square. Okay, I am writing only the magnitude of this electric field. Okay, this is only the magnetic field I am writing. Okay, this is only the magnitude I am writing, sorry. Okay, so this will be your electric field due to this charge element, and that will be in this direction. Okay, that will be in this direction. So this will be equal to what? If I put the values here, put the value of dq. Okay, then dq is what? dq is lambda dl, and this r square, that will be equal to x square plus r square. We know that, and also this k, that will be equal to 1 over 4 pi epsilon naught, right? Okay, so from here I can write that. Now let me consider another charge element here of similar length dl, and that is this second charge element. This is diametrically opposite to this charge element. Okay, so electric field due to this will be in this direction. Okay, electric field due to this first charge element and due to this second charge element, they both have same magnitude. Okay, and making same angle with theta, but their orientation, they are different, right? So from here, from this figure, I can say that their vertical element, their vertical components, they will cancel each other. Okay, if I resolve these two electric fields into their horizontal and vertical components, their vertical components, they will cancel each other, while their horizontal components, they will add up. If I assume any charge element on this ring, then there will be an element diametrically opposite to it. Okay, diametrically opposite to it, such that it will cancel out vertical component of the electric field, right? So due to this charge ring, we can say that electric field due to this charge ring, that will be in the horizontal direction. That will be only in the horizontal direction, because the vertical components of the electric field by the diametrically opposite elements, they will cancel out each other. Okay, so I can write that this electric field, that will be what? Or let me write that this electric field will be only in the x direction, and that will be only the x component of it. So I can write that this will be this integration dE cos of theta. Okay, integration of dE cos of theta. Now what is cos theta? So I can write that this cos theta, again from that right angled triangle, I can write that cos theta will be x divided by square root of x square plus capital R square. Okay, so I can write that this will be equal to x divided by square root of x square plus capital R square. Now if I put this expression here, what I will get? I will get the total electric field, which is only the x component, that will be equal to k lambda dl divided by x square plus r square into cos of theta, that is x divided by square root of x square plus r square. So this Ex, that will be what? That will be equal to k lambda dl divided by x square plus r square raised to the power 3 by 2. Okay. Now, as this charge is only distributed along the circumference, okay, along the circumference. So what this dl will be after integration, what I will get here, okay. Let me again write that this Ex, that will be equal to what? That will be equal to k lambda. I can take this k and lambda outside from integration because they both are constant, and also x is constant and capital R is constant. So I can write that k lambda divided by x square plus r square raised to the power 3 by 2 into integration over the whole circumference. Okay, so this length is actually an element of the circumference. So our limits, they will vary from 0 to 2 pi r. Okay, they will vary from 0 to 2 pi r. Okay, or what can I say? Or also one thing I can do from here, that if this is your circumference, then this charge element, this dl, that will be equal to what? That will be equal to r d theta. Okay, r d theta, as I am taking also this angle as theta, so I am assuming here another variable, okay, this variable, and I am taking this variable as what? I am taking this as d alpha. Okay, so this dl we can write as r d alpha. Okay, so I can write that this Ex, that will be equal to what? That will be equal to k lambda x square plus r square raised to the power 3 by 2. Raised to the power 3 by 2. This dl is what? This is r d alpha. And alpha is this angle which is varying from 0 to 2 pi, because it is making if I want to take integration around all of the circumference, around this circumference, then this angle alpha, that varies from 0 to 2 pi. Okay, in covering this circumference, this angle alpha, that varies from 0 to 2 pi. So I can write this Ex as k lambda r divided by k lambda r, and there will be one x also here. Okay, so k lambda rx divided by x square plus r square raised to the power 3 by 2. Okay, this r comes outside of this integration, and if I integrate this much only, so now integration is this much only. Okay, so you can write it as that Ex will be equal to what? That will be equal to k lambda xr divided by x square plus r square raised to the power 3 by 2 into 2 pi. That 2 pi comes from this integration. Okay, so I can write, if I put the value of lambda here, suppose a charge plus q is distributed over the string. Okay, suppose a charge plus q is that total charge that is distributed over this ring, that is capital Q, capital plus Q, then you can write that this lambda will be equal to Q, capital Q, divided by the circumference of the ring, and that will be equal to 2 pi r. Okay, if I put this much here, then what I will get, and in place of k I am going to put 1 over 4 pi epsilon naught. This lambda is Q divided by 2 pi r, and then 1 r here, 1 x is here, then divided by x square plus r square raised to the power 3 by 2 into 2 pi. Okay, then this 2 pi r is cancelled out, and what we are left with? We are left with 1 over 4 pi epsilon naught qx divided by x square plus r square raised to the power 3 by 2. Okay, this much will be the electric field. This much will be the electric field due to this charged ring that is having a total charge plus Q plus capital Q uniformly distributed over it. So this is the electric field on the axis, on the at a point P, which is on the axis of the ring at a distance x from the center, and this plus Q charge is distributed uniformly over the ring, and this ring is having a radius r. So this much will be the electric field. Now let me discuss with you that what will happen if this point is much far away from the ring. That is, we can say that this x is much greater than r. Okay, then this implies that r by x, this is much less than 1. Okay, so in this expression, if I take x square common from this bracket, then what I will left with? I will left with 1 over 4 pi epsilon naught qx divided by x cube 1 plus r square by x square raised to the power 3 by 2. Okay, so this rx is much less than 1. So this r square by x square, that will be far less. Okay, so I can neglect this. Okay, I can neglect this r square by x square as it is much less than 1. Okay, as it is much less than 1. So I can write that this ex, that will be equal to 1 over 4 pi epsilon naught q divided by x square, as we are neglecting this one. Okay, so this much will be the electric field at the axis of the ring at a point which is lying on the axis of the ring. This much will be the electric field if that point is very much far away from the center of the ring. Okay, now let me discuss another case. Okay, and that is what, suppose this particle, this point, okay, suppose this point is at the center of the ring. Okay, so what will be the electric field at the center of the ring? So this ex, that will be equal to 0. Okay, so at the center of the ring itself, that electric field will be 0. Okay, so in this way we can find out electric field due to a continuous charged body. Okay, thank you.